Hello, my name's Andres Marron. Oh, sorry about this. I'll get this out of the way. Hello, my name's Andres Marron, and I paired up with Christian and Marcus to do this class project. And we decided to do the NE Grand Challenge of Restoring and Improving Urban Infrastructure. So, the NE Grand Challenge of Restoring and Improving Urban Infrastructure was established with the hope of future engineers providing solutions to the United States' infrastructure issues. So you might be wondering to yourself, well, what exactly is infrastructure? Well, according to the NA website, infrastructure is the combination of fundamental systems that support a community, region, or a county. It includes everything from water and sewage systems to road and railway networks to the national power and natural gas grids. And it's becoming an issue because over the past decade, the spending on U.S. infrastructure has rapidly increased and reached a grand total of $416 billion in 2014. And this was only to transportation and water infrastructure. So you might be thinking to yourself, if you spend that much amount of money, then you should have a fairly decent infrastructure. But that's not the case with the United States. The American Society of Civil Engineers released its 4-year report card of the condition of the U.S.'s infrastructure, and it was given a D minus. And it said that it could decrease in the future due to the population growth, which would obviously lead to a higher usage of the infrastructure. So bridges would be worn down more easily. Metro systems would have more problems in the future because they're being used more constantly and stuff like that. So what my group and I decided to do is that we decided to focus more on the transportation aspect of the infrastructure. So let's get to it. So the first part of our code, before I get started, I need to show you that in order for this code to run, the data and the project have to be saved on the same folder, which is over here. Sorry about the background. So as you can see right here, they're saved on the same folder. So the first part of this code, I'm going to give you a quick description of the first part. The first part of the code gives you a menu of 15 southern states, and you choose one of the states, and then you choose a mode of transportation. After you've answered those two questions, it'll display the population of that state in 2010 and the amount of people that use that mode of transportation to get to work in 2010. And it'll do the same thing for 2015, and then it'll predict it for 2020. Sorry about that. So here you have the Excel sheet, and this gathers all the data from the Excel sheet from over here. And over here, transportation percentage. So 86.1% of people use cars to get to work every day. And then 0.5 use public transportation, 0.1 use taxi, 0.2 motorcycle, and so on. Bike, walked, other, worked at home. Worked at home means, well, they didn't use any type of transportation because they didn't need to get to work. Other includes carpooling and stuff like that. Walking, biking, self-explanatory. So in this part of the code, what Christian did was he established all of our variables. So Alabama right here, that's the population of Alabama in 2010. You do the same thing for 2015, then Arkansas, Florida, Georgia, all the way down to West Virginia. And then we go to, our first question. Our first question is a menu, and it gives you the 15 states. And you pick a state, then you pick a mode of transportation, and it gives you the data. So let's run it. So you run it, and it'll show you the 15 states. Let's pick North Carolina. And I want to learn about how many people walked to work in North Carolina and will walk to work in North Carolina. So population in 2010 was this. Population that walked was that. Same thing for 2015. And then the prediction for 2020 and the prediction of how many people are going to walk to work in 2020. So what we did was over here is we set question 1 equals to menu this, the 15 states. Sorry about that. If question 1 equals 1, which means if question 1 equals Alabama, then it goes directly to our next question. And our next question was lets the user pick a mode of transportation. So then you go down here and population. So let's say you pick Alabama and you pick car. So population in 2010 was Alabama. People that will commute in cars in 2010. There you go. It'll display it. Skip a couple lines. Population in 2015. Skip a line. Commuting cars. And then the prediction for 2020. And here are our variables. The first one being the population of Alabama in 2010, which Christian defined above, over here, right here, Alabama. There you go, from 2010. And then we multiplied it by the percentage of cars, by the percentage of people that that commuted to work with cars. So that'll give you your second output. Same thing for Alabama 1. Alabama 1 means the population in 2015. You multiply that by the percentage that we used here, the car percentage, and that'll give you the next output. And then for 2020, what we did is we found the difference between the population in 2015 and the population in 2010, and then we added the difference to the population in 2015, giving us the population in 2020. So then again, we multiplied that by the percentage of cars, and that'll give you the amount of people that we have predicted that will ride their car to work every day. And it works for all of the states. So you can pick, I don't know, Louisiana, and let's say how many people walk to work in Louisiana. So population in 2010 was this. People that walked to work in 2010 was this amount. And then again in 2015, and then the prediction for 2020. So that's our first part of the code. Our second part of the code goes hand in hand with the first part. Our second part of the code is basically the same thing, but it shows you it's more of a visual representation. It shows you graphs for each type of transportation, and it'll show you the amount by which it's increasing. So it'll show you how many more car commuters there are per year, for example, or how many people walk per year, and how many will walk. How much are being added. There we go. That was a better way. So in the first part, same thing, question, menu, and it gives you the 15 states. You pick one, and let's say over here, if question equals 1, so let's say you picked Alabama, well then data equals this, and then all this stuff, and it'll show you seven bar graphs, one for each mode of transportation, and then you go to the command window, and it'll show you by how much each transportation is, or how much the usage of each transportation is increasing by. So here, this number right here represents the population of Alabama in 2010, and you multiply it by the percent that use cars. Same thing for 2015, and same thing for 2020. And we found this number by subtracting this number from this number and adding it to this number, giving us the 2020 population. And then you multiply by the percentage. So let's run it, and then I'll describe it with further detail. So let's say, again, you pick Alabama, and then it'll show you 7 graphs. And each graph, obviously labeled y-axis, x-axis, growth, title. And each graph shows you So for this one, for example, growth of people with other forms of transportation. Same thing for walking, same thing for bicycles, motorcycles, taxis, public transportation, and car commuters. Now, obviously, bar graphs are kind of hard to read when you're dealing with such big numbers. So what we did on the command window is that it shows you by, the slope of each graph. So there is an increase of 13,578 car commuters per year. And then same thing for public transportation, taxi, motorcycle, bicycle, walkers, and other forms. And what we did was we set Alabama is equal to data 1, first row, all the columns. Your x-axis is your years, and this also is how you label your bar graphs. So 2010, you were increasing it by 5 years, so 2015, and we stop at 2020. So that gives us our 3 different bar graphs. And then you plot them. So x-axis being your x information, which was up here, your years, and your y being the data that we computed up here. And then you label them, y label, title, and then to find the difference in each year, I decided to use polyfit for here. So linear Alabama car equals polyfit. There you go. That gives you your M1, which is the slope, which shows you by how much each is increasing. So there is an increase of car commuters per year, and then you have to write M1 times 10 raised to the 6, because since we're dealing with decimals, you have to do this in order for the command window to show as whole numbers. Because if what was happening was if you're working with millions of numbers, then the M1 won't print out the same. And we're working with decimals because bar graphs are very hard to read, or pretty hard to read if you're working with millions. So we decided to use decimals so we could zoom in on the bar graphs and actually see the difference in growth. So that's why over here you have to raise it by 10 to the 6 to give it to you in a whole number. So then same thing for public transportation. Same thing for all of them, really. Very long code, but it gives you basically everything you need to know. So you can run it with, Kentucky, and it'll show you all of Kentucky's information, or that we provided. So growth of people using other transportation, growth of walkers, bikers, using motorcycles, using taxis, public, and cars. And as you could see there, the bar graphs were kind of hard to read, which is why we put this part of the code. This tells you exactly how many more car commuters there are per year, and same thing for public transportation, all of them. And as you can see, it works with every state. So Tennessee, same thing. It'll give you seven different bar graphs, and it'll show you the slope of each mode of transportation and how much and how much it's increasing by. So there are some limitations to this code, and one of the limitations is that we assumed that the percent of people riding their car to work stays the same. We assume that the percent of people riding public transportation stays the same throughout the 10 years. We assume that for all modes of transportation, which, as we know, could vary over time. In 2010, it might have been 86%, but in 2011, it could have been 95%. We assume that it would stay throughout. It would stay the same throughout the 10 years. The growth in state is also a limitation. We assumed that the rate at which the states would grow would stay the same. So we assumed that from 2010 to 2015, the growth was going to be the same as from 2015 to 2020, which, as we know, could very well be different because a state's population could expand exponentially, or it could be reduced. You know, you never know. Maybe there was a natural disaster and people had to evacuate, reducing the state's population, or God forbid there was like a plague or something. I don't know, but that's one of the limitations. And although we don't provide a solution, and we don't tell the user how to the fix infrastructure. What it does show, it shows where the government and civil engineers need to focus on. No? So, for example, if in Louisiana there's 10 million people riding their bike to work in 2015, and then there's going to be 20 million in 2020, well, then you know you need to work on your bike paths and your sidewalks, and providing safer paths for bikers on roads. But on the contrary, if you look at Louisiana in 2015 and there's only 500 bikers, and then you look at 2020 and there's only 600, well then, you know, you don't have to focus on that type of transportation. Or not that you don't have to focus, but you can invest in other forms of transportation. You know, you can invest more money into public transportation, or you can invest more money into highways. So, like I said before, it doesn't provide sorry about that. It doesn't provide you with an answer, but it does show you where you need to focus on, where the government could invest more money, or where basically where the government needs to focus on, what to expect in 2020. Thank you, and I hope you enjoyed this presentation.